Hello. Today we're just going to get the basic forms, the complete set of basic forms of antiderivatives. And these are all the different basic forms. When you see an antiderivative when you're trying to find the antiderivative of one of these functions, you can just go ahead and write what the antiderivative is, because these are the reverse of the things that we've seen previously. All the different derivatives we've seen previously and what we've talked about. So I'm going to give you the entire list. The first, the antiderivative or integral of x to the n, where n is not equal to -1, is 1 over n plus 1, x to the n plus 1 plus c. Your reverse power rule. 2, the second, the special case, antiderivative 1 over x is the natural log absolute value of x plus c. We only use natural log when it is 1 over x. Any other power, you use the reverse power rule. 3, we have the reverse of the 6 trig functions. The antiderivative of sine of x is the negative of cosine of x plus c. 4, the antiderivative of cosine of x is sine of x plus c. 5, the antiderivative of tangent of x, we just talked about, is the natural log absolute value of secant of x plus c. 6, the antiderivative of cotangent of x is the natural log absolute value of sine of x plus c. We have 7, the antiderivative of secant of x is the natural log absolute value secant of x plus tangent of x plus c. 8, the antiderivative of cosecant of x is natural log absolute value cosecant of x minus cotangent of x plus c. Okay, that takes care of the antiderivatives of the basic trig functions. We have the reverse of the derivatives. So we'll keep these with trig, the trig derivatives. For example, the antiderivative of secant squared of x was tangent of x plus c. The antiderivative of cosecant squared of x is negative cotangent of x plus c. The antiderivative of secant of x tangent of x is secant of x plus c, and the antiderivative of cosecant of x cotangent of x is negative cosecant of x plus c. This takes care of antiderivatives, basic forms that are trig, whether they're basic trig functions, the first of 6 of these in black, or the reverse of a trig derivative, which is these last 4. We have exponential, and there are 2 types. We have the antiderivative of e to the x, which is e to the x plus c, and a more basic, the antiderivative of b to the x, where b is not the number e, and this is 1 over natural log of b times b to the x plus c. We have the inverse trig. We have 15, the antiderivative of 1 over the square root of 1 minus x squared If you remember, that was arc sine of x plus c, and the more general arctan that I just talked about, 1 over x squared plus a, where a is greater than 0. And this is 1 over the square root of a, arctan of x over the square root of a plus c. And then finally, and I think I'm out of colors here, unfortunately, there are two more, the hyperbolic. And so I guess I'll go back to purple, if I can find purple. We have the antiderivative of sinh of x is cosh of x plus c, and finally the antiderivative of cosh of x is sinh of x plus c. These are the ones that you really should know and be able to use. These are the basic forms at this point. That you notice there's still some functions that we've talked about that we don't have the antiderivatives of. For example, the antiderivative of natural log of x. You'll get that in Calc 2. The antiderivative of arc sine and arc cosine, those functions. We don't know what those are yet. You'll get those in Calc 2. This is the basic forms. So when you see an antiderivative, or you're trying to take an antiderivative, you want to use algebra, trig, or U sub to end up with a basic form.